Hey everyone, Toby from Humanitec here. In today's product tip, I'm going to show you how you can run your Terraform code inside your own infrastructure when you're provisioning resources through the Humanitec Platform Orchestrator. This has been possible before, but we just introduced a new feature that makes this a lot easier to manage. So let's see how that works. Let's take a high-level view at your setup first. Let's say we got the Humanitec Platform Orchestrator shown here on the left, and on the right-hand side is your infrastructure with your target Kubernetes cluster running the Humanitec operator. Now let's say you wish to deploy a simple workload. The workload is dependent on a set of resources. It can be anything, an S3 bucket, some other storage, databases, whatever. So you're going to have a resource graph looking similar to this one. At deploy time, the Platform Orchestrator will create a set of Kubernetes custom resources in your cluster representing that resource graph. The operator will see it and start to act on it. Let's say it wishes to provision this particular resource. It finds that it's supposed to be done through Terraform, so it will call back to the Platform Orchestrator and call the Terraform driver. The Terraform driver will obtain the Terraform code, and to actually execute it, it will call a runner instance that it instantiates for this purpose. The runner is a temporary thing that lives only as long as the Terraform execution is being performed. Now the runner will need access to your Terraform state, and that's an issue because your Terraform state will probably be located in a very secure location somewhere inside your own infrastructure. And what you usually do not want is some external system like the Humanitec Platform Orchestrator accessing your secured state. So this access is not what you want. Instead, we offer a way to move the runner into your own infrastructure. You can specify the target cluster that it's supposed to be executed in. It can be the same cluster housing your workloads or a separate one dedicated to this purpose. From here, the runner can securely access your state and perform the provisioning of our resource. All good. Great. Let's look at a real-life example. We have prepared a small sample deployment through a score file. So let's look at our score file real quick. The user score file is very, very simple. It's just running a basic BusyBox image, doesn't really do anything. Down here, we have two resources though. We have bucket 1 and bucket 2, and they are of type S3. So this is obviously an AWS demo setup. Those S3 resources are going to be provisioned through Terraform using the runner setup we just saw. Let's look at the target cluster real quick. Let's look at the namespaces. And on our target cluster, we have a particular namespace dedicated for the purpose of a Terraform deployment. It's called Humanitec Terraform. You can change the name, but that's the default. And that is the namespace that will house the execution of the runners. So we will see Kubernetes jobs and Kubernetes pods being created when the execution is actually being performed. So let's set a watch onto the jobs in that particular namespace. And let's also set another watch at the pods in this particular namespace. Kubernetes jobs will spawn Kubernetes pods. The pods will be the actual runners. Cool, nothing happening as yet, which is cool because we did not start the deployment yet. But I'm going to do that now. Do a humcuttle score deploy with a wait flag so we can see the pipeline output. Let's zoom back out. And as the pipeline starts, we should now see the jobs being created up here. There we go. Here's number 1, number 2. It's 2 jobs because we requested 2 S3 resources. And because they can be executed in parallel, since they're not dependent on each other, we see those 2 jobs running at the same time. So those two Kubernetes jobs should now spawn Kubernetes pods any minute now. That's the job that Kubernetes has to do. Nothing we can do to speed that up. There we go. Here's number one, creating, running, completed. And here's number two, also running and completed. Splendid. So moving over back to our pipeline, we should now see that the pipeline moves from an in progress state to a successful state any minute now. And there we go. Bucket 1 has been successfully provisioned. Bucket 2 has also been successfully provisioned. Our workload has been provisioned and our pipeline run is succeeded. Let's switch over to the Humanitec portal to see what was created. So this is our fresh deployment, and we can see that the resource graph shows the workload itself plus the two S3 resources that were requested through the squad file. There's more stuff in the graph though. There's a config resource that we did not request, and there's also an agent resource we did not request explicitly. And where did they come from? So in a nutshell, those S3 resources are about the S3 things only. They know how to deploy an S3 bucket, whereas the config resource is all about the execution of the Terraform runner. Let's look at the resource definitions that are backing those resources, starting out with the S3. So here's the type S3 resource definition, and it's of a driver type called Terraform Runner. That is the new capability that I just mentioned at the start. It's a new feature we just released. It's a driver that is an alternative to the well-known Terraform driver. In fact, it's a simplified version of the Terraform driver because it is concentrated on the things that are Terraform only. It expects the stuff that are Terraform, like input variables, the actual Terraform code, and not much more. This particular resource definition doesn't do much. As you can see, it's an inline Terraform script that does not actually provision an S3 resource. To keep things simple, we don't do that. We just provide the required output variables so that the orchestrator is happy and leave it at that. And that's it. The information, how to actually spawn the runner and where to execute it, is placed in a separate resource definition. That is the config resource that we just saw in the graph. So here's our config resource definition using the template driver. And what it does is it provides all the information where to find the cluster for the runner execution. So here's the cluster information. Here's the target namespace, Humanitec Terraform, the one that we just saw. It's going to use the service account like this, and it's going to use the Platform Orchestrator cloud account named here to get physical access and proper permissions to access the cluster. What it also does is it requests an instance of the Humanitec agent that is also configured in the Platform Orchestrator. This is not the topic of our demo today. Just so you know, the agent is a way to set up a secure channel from the orchestrator to your cluster so you can work with private clusters as well. So in a nutshell, you have all of the all of the infrastructure aspects condensed in this particular resource definition, and all of the resource aspects, so all the things S3, are in this resource definition. Previously, they were all mixed in together using the standard Terraform driver, and that's kind of hard to manage because you will have a lot of redundancy, you will have no separation of concerns, and you have both of these things resolved now. You have a clear separation of concerns, you have S3 resources that are about S3 only, and you have this config type thing and the agent things, which are about the infrastructure aspect only. You can maintain each of them independently and can reuse this config resource definition for any type of resource that you want without having to repeat yourself when you add it all up in the classical Terraform Runner way. And this is it. All you need to do is use that new runner type called Humanitec Terraform Runner, and there's a wonderful documentation page in our developer docs. We're going to put you the link to this page into the info box to this video. And this was it. I hope that was useful. Until next time, take care.